Hi there YouTube, and welcome to my lesson on ionic bonding. Ionic bonding is when one metal element bonds together with one non-metal element. The reason they have to be metal and non-metal is that when two metal elements join together, they form something called metallic bonding, and when two non-metals join together, they form covalent bonding. And both of those two types of bondings is very different to ionic bonding. So it's important when you're looking at ionic bonding that your two elements are metal and non-metal. So I'm going to start this lesson by drawing an atom. I presume you already know about the structure of an atom. However, if you do not, I would recommend watching my other videos which explains the structure in a lot more detail. So here I'm drawing chlorine, and it has 17 electrons on the outer shell. I'm just checking that's right. Yep, 17 electrons on the outer shell. Sorry, 17 electrons in total. So these circles, as you probably guessed, are the electrons, and you can probably see I am drawing them in different layers. Now these different layers are called shells, and each shell holds a certain predefined number of electrons. That number is the maximum amount of electrons it is able to hold. So on the first layer it can only hold 2 electrons. On the first layer it can only hold 8. So on the second layer it can only hold 8. And on the third layer again it can only hold 8 electrons. Now for the first 3 shells they fill up in order. So the first layer fills up, second layer fills up, third layer fills up. And when an element is in suspension, its desired presence is to only have full shells. If you hadn't noticed, the final shell only has 7 electrons. So its desired effect is to have full shells, even if that means getting rid of some electrons. So for chlorine to gain full shells, it has 2 choices. It can either lose 7 electrons, so it only has 2 shells but they're full, or gain 1 electron and have 3 full shells. The atom isn't concerned about the number of shells it has, however it is concerned about how easy it is to do this. And what do you think is easiest, to lose 7 electrons or to gain 1 electron? Well, the answer is to gain 1 electron, as common sense really. It's only 1 rather than moving 7 electrons. So this is trying to gain 1 electron. So let's draw another element which is very reactive with chlorine, and I'll explain why it is very reactive. So let's draw lithium. Lithium has 3 electrons. So it has 2 in the first shell, because only 2 can fit in there, and there's 1 on the second shell, because it only has 3 electrons. It hasn't quite filled up, but it hasn't filled up at all yet really. So it's again lithium is trying to only have full shells left. And unlike chlorine, the easiest method of getting there is by losing one electron instead of gaining 1, because in order for it to get a full shell by gaining electrons, it would have to gain 7 electrons. And obviously it's a lot easier to lose 1 electron than gaining 7. So here we have lithium. and it is trying to lose one electron. So you're looking at this text here, and you sort of think, well maybe these two elements could help each other out. You've got one person trying to get rid of one electron, and another person trying to gain one. Well, the most simple and common sense thing for the process to happen is for lithium to be very nice and give one of its electrons to chlorine. So this electron is no longer here, and it gives it here to here. Notice I've drawn a cross here because I've just drawn a different way of showing it to clearly demonstrate that it is a different electron. It's come from somewhere else, but they are the same. I'm not trying to confuse you. It's just to make it look better. But anyway, let me just pause the video quickly. Okay, I'm back. So what I was saying is that you've got the three electrons on the one electron on the outer shell wanting to move to the chlorine because it's looking to gain an electron. And when it gives away an electron, it loses a negative charge because all of the electrons have a negative charge, and inversely, all protons have a positive charge. So before this lithium element gave away its electron, it was balanced because it had 3 protons and 3 electrons. But now it only has 2 electrons. So that means it has 3 protons, 2 electrons. So it means it has a positive charge because it's more protons than electrons, and the counter of that is 1. There's 1 extra proton. So on the other side of the thing, we have chlorine. Now chlorine has 17. Originally it had 17 electrons and it has 17 protons. So when it gained an electron, it gained a negative charge. It gained 1 negative charge because it gained one lithium. Because it gained 1 electron. If it gained 2 electrons, it would be double negative. But we'll just keep it simple, we'll keep it at 1. So we have our new element, and it's lithium chloride. And it does not have a positive negative charge, because you have a positive charge here and a negative charge here, which balances the equation. So you have your first shell, you have 2 electrons, your second shell, you have 8 electrons, I'm not bothering to draw the rings around it right now, but hopefully you can see the different shell layers. And I'm going to draw this electron with a cross because it came from the lithium. So now we have here an element where all the shells are full, and this actually determines how reactive elements are. So if you have an element with say, which needs 2 electrons, and you have 2 other elements which are giving away 2 electrons, those elements will react together very, very easily. And it's the same. Sorry, no, it's not the same reason. It's the reason which determines the reactivity of 2 different elements. I can also show you now how to draw this, how to write this in a proper format. So in both of these examples here, I've been drawing all the electrons in outer shell. No, this isn't necessarily essential for understanding ionic bonding. However, it may be essential in your exam. So we have chlorine. This is how to draw it in a proper format. And we only draw the shell. We only draw the electrons which are on the outer shell. Yeah, we only draw the electrons. We only draw the shells which are not full. So we have first 2 electrons in the middle which are full, and the 8 electrons on the center shell which are full. So they're full, they're not necessary, they're not going to change, we're not going to draw them. And we write down here 2, 8, 7, because that's the number of electrons in each shell. And then to the right we have lithium, and we're just simply going to draw 1 electron, and we're going to write 2, 1. And now, if I've got enough space, I'm just going to try and make do with what space I have here. I am going to draw I'm going to draw lithium in square brackets. I'm not going to draw any electrons because it's lost all the electron on the outer side. So I'm just going to write 2 positive because it's a single positive charge. And then you can also draw, you also have to do a plus here to the right for square, top right for square bracket. And now I'm going to draw chlorine, and I'm going to draw the electrons for this one. Even though it has a full shell, I'm going to draw it because this is where the extra electron has gone to. You can draw the circles if you want to, however it's not necessary. I prefer not to do it, just I think it makes it look neater. So now we draw the shell arrangement, so it's 288 with a single negative charge, and in the middle we draw the element. We write the new elemental symbol, which is lithium chloride, and this is basically how you draw it. So you need to make sure you have square brackets, and essentially just make sure it looks like that. I know it's not the neatest, but so you're making sure it looks like this. I know it's not the neatest way to present it with all my clutter around it. However, this is the official way you have to present it, especially when you're doing tests and exams. So essentially, just to conclude, ionic bonding is the giving of electrons, and it gives away electrons when it's easiest to give away, and elements gain electrons when it is easiest to gain. So if it has 3 electrons on the outer shell, it is easiest to give it away. When it has 5 electrons on the outer shell, it is easiest to receive electrons. So I hope you learned something on this video. If you want some further videos, or if this helped you on your understanding of ionic bonding, please subscribe to my channel and like this video. I'm always looking for feedback on my videos, so I'd really appreciate it if you were to comment or give me a message on how I can improve my videos. Thanks for watching, and goodbye.